All right, we're going to continue our lessons of properties of real numbers, and today what we're going to do is look at how to compare and order numbers. Now, a lot of what we're going to do with this, there we go, will be estimation and using some things that we've talked about with exponents and roots, and then we'll talk a little bit about fractions so that we can estimate values of numbers, and we're going to do several things with them. The first thing we're going to do is place them on a number line. We're going to order them from least to greatest or greatest to least, and then we're going to look at maybe how to compare them as far as less than, greater than, and equal to. All right, so our first task that we're going to look at is how do we place numbers on a number line. And so some of them are a little bit more direct. So for example, negative 8.3. So if I go along my number line, I go negative 8 right here. Now negative 8.3 is going to be past 8 in the direction of negative 9. So, and it's not quite halfway. So let me change here to a little darker color. And so we would just put a dot right here. So that's negative 8.3. All right, and that's all you need to do. Now, 4.6, once again, I got to move from 0. I go to 4, and then 4.6 is going to be past 4. It's a little bit more than halfway because 4.5 would be halfway, and then I can just label like so. Now, 2 to the third, all right, we're going to use some of the things that we talked about with exponents. Remember, this means I need to multiply 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8. So that is exactly 8. So I'd put my dot right there, and I'm going to label this as 2 to the third. All right, so now when we get to a root or a radical, we're going to use some of our estimation skills. Now, so what will happen is if you memorize or just get to know your perfect squares all the way up to maybe like 12, that will help you estimate this. So for example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and on and on and on. And remember, when we go backwards, we're taking the square root. So the square root of 1, all right, is 1. Square root of 4 is 2, or negative 2. Now, what we're going to do here, and I know when we did the root lesson, we put that it was 2 or negative 2. When we're ordering numbers and we're looking at numbers, we're going to assume that if we just have the radical here, it's wanting the positive root. Versus if we see this, we want the negative root. So we're going to assume that this is going to be a positive solution. Now, 5 is between 4 and 9. All right, so the square root of 5 has to be between 3 and 2, because notice, if I took the square root of 9, that would be 3. If I took the square root of 4, that would be 2. So what I know is that the square root of 5 has to be squeezed somewhere in the middle here. And notice 5 is closer to 4, so the square root of 5 is going to be closer to 2. So it's going to be a little bit more than 2, and then we would just kind of estimate, all right, square root of 5 like that. Now, looking at this, when we look at fractions, we want to think about how many wholes do we have. So for example, if I have 6 in the denominator, for every 6 in the numerator, I get 1 whole. So negative 7, 6 is going to be a little bit more than 1 whole. So 1 whole would be negative 1, and I have a little bit more than that. So I would place my number on the number line just like so. All right, so that's kind of how you estimate and work with that. So what I'm going to do is give you one problem to go ahead and try right now. So go ahead and pause the video, all right, and place these 5 numbers on the number line. All right, let's see how you did with this. All right, negative 3 squared. All right, if we go back and think about what we talked about with exponents, I'm going to do that right up here. Negative 3 squared would be negative 3 times negative 3. Remember, a negative times negative is positive, and then 3 times 3 is 9. So that would be exactly 9. So I'm going to put a dot right there, and then I'm going to just label that one. Okay, now we have 9 elevenths. Now remember, 11 out of 11, all right, if I had 11 out of 11, that would be 1 whole. All right, now 9 is a little less than that, so this isn't quite 1 whole. It's positive, so it's going to be a little less than 1. All right, more than halfway. All right, so there's 9 elevenths. Now the square root of 16 is just 4. 4 times 4 is 16. So once again, that's exactly 4, so we're going to put our dot right there, just like so. All right, so now we have a negative number. We want to think about how many wholes we have here. All right. So when I look at this, okay, so 4 over 4 would be 1 whole, and then if it's negative, it would be negative 1 whole. And then I'd have, if I had 8 over 4, that would be 2 wholes, and then 12 over 4 would be 3 wholes, and then 16 over 4 would be 4 wholes. Now look, 15 over 14 is right here. It'd be in between these, and if these were negative, so this would be like negative 1, negative 2, negative 3, and then negative 4. All right? So negative 15 fourths is almost to negative 4. So then we can label that guy and put it right there. Now 7.56 is a little bit more direct, so here's 7, and then 7.5 would be here, so 7.56 is just past halfway. We would label that like so. Alright, so there we go. Now let's look at another idea, which is trying to order our numbers from least to greatest. Now, when you have a bunch of numbers, you typically want to try to convert them maybe to something that you can see and compare. In this case, they're all in decimals, which is great. That makes it a little bit easier to look at. Now, the other thing is that when we have decimals, what we really want to do is we want to write all the numbers with the same amount of decimal places, all right, so it makes it easier to compare. And so to do that, all we have to do is add zeros. So as I look through my list of numbers, this has the most decimal places, which is 3 decimal places. So what I'm going to do is add zeros so that they all have 3 decimal places. So I'm going to rewrite this as negative 4.320, negative 4.3, and then I'm going to add 2 zeros. This is already up to 3 decimals. Then I'm going to add a 0 here. I'm going to add 2 zeros here. And then I have this guy. Alright, so now this allows us to compare things in the same types of units. So these are all, so tenths, hundredths, thousandths. So this is like 890 thousandths. And for what we can do is we can still use what we know that 890, for example, is bigger than 500. And so that's how we can, if we convert everything and change it so they all have the same amount of decimal places, it makes that comparison a little bit easier. Now, the other piece, there's 2 other things that we need to look at. One is that these are all negative numbers. And we have to remember that the larger negative number, the farthest to the left or the least, all right, number we have, all right, or the lesser number we have. The other thing is that if all of the digits here are equal, we go to the next thing to look. So now if I look at this, all right, and I go from this, this is clearly the biggest negative number we have. So it has to be the farthest to the left. All right. Now, when I look at these 3 numbers, the first digit is the same. All right. They all have negative 4. The second digit is the same. And then even the first decimal is the same. And then the second decimal is even the same for some of these. But now look at what we can do. This is negative 4 and then 566 thousandths. And then 560 thousandths. And then 500 thousandths. So 566 is bigger than 560 and 500. So since this is the bigger negative number, it has to be farther to the left. So it would be like this. And then we have negative 4.560 and then negative 4.500, like that. Now once again, then we get to these numbers. The first decimal is the same. And then the 3's are the same, and then the 2 is here. So 320 is a bigger decimal than 300. So that makes this a bigger negative number, which means it's the lesser number, so it has to go farther to the left, like so. Alright, and so when we look at this, I can see that these numbers are getting bigger in the negative direction. All right, and once again, if we think about our number line, we know that we have 0, then negative 1, negative 2, and then all the way out to negative 10. So we know as we go farther to the left, the negative numbers actually grow in value. All right, and it would also makes them lesser because you would probably prefer to owe me $1 versus $10. All right, so owing me $10 is a much greater debt or a larger negative number. All right, let's look at another example. All right. Now this has a mix of fractions and some radicals in here, some roots in here. So we're going to just kind of estimate. So now once again, when we look at 10/15ths here, all right, we can kind of look at what we have. So 10 over 10 would equal to 1. 20 over 10 would equal to 2. That would be 2 wholes. Now if we look, 15 over 10 would be directly in the middle of these two, which means then it would have to be directly in the middle. So that's like 1.5. Alright, so we can kind of estimate that. Now, when we get to this, we have 7 over 8. Well, remember, 8 over 8 would be 1 whole. So 7 over 8 is a little bit less than 1. Alright, so I'm just going to kind of say, you know, a little bit less than 1, and then we'll kind of come back to that. Alright, now we have the square root of 8. Now, once again, if we look at some of our numbers and we start going through them, alright, so let's do our perfect squares. Okay, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Well, if we look, square root of 8 is just before the square root of 9. So it's going to be just a little bit less than 3. All right, so that's a little bit less than 3. All right, now we have the square root of 26. So let's keep going here. So the square root of 16 would be 4. The square root of 25 would be 5. And then if I go to my next perfect square, that would be 6. Well, 26 is between 25 and 36. It's just past 25. Just past 25. So the square root of 26 is going to be just past 5. So this is a little bit greater than 5. And then let's look at 19/4 and see how many holes we have here. So once again, 4 over 4 is 1 hole. 8 over 4 would be 2 holes. 12 over 4 would be 3. And then 16 over 4 would be 4. And then 20 over 4 would be 5 holes. So when I look at this, 19 over 4 is just before this. So it's not quite to 5. So this is a little bit less than 5. Now, so notice I'm not really trying to get exact values right now. All right, because I might be able to order them based on what we have. So when I look at this, I've got 1.5. This number is slightly less than 1, a little bit less than 3, a little bit more than 5, and a little less than 5. That is enough information for me now to put these in order, because since this is less than 1, everything else is bigger than 1. So this has to be the least number. All right, so we've got this one. Now this is 1.5, so it's going to go next. And then I have a number that's a little bit less than 3, so that would be the square root of 8. Then I'm going to jump over here because this number is bigger than 5. This number is smaller than 5, so it has to go here. And then this is bigger than 5, and now we have them in order. So we're just estimating, trying to get those in order, all right, and kind of compare them. All right, so now let's give you a shot. Now this has a mix of decimals, all right, and fractions and roots. All right, so you're going to have to kind of put all those things together that we just discussed. So go ahead and pause the video and put these in order. All right, so let's see how this worked out for you. Now, so when I look at this, the first thing I'm going to do is I've got 3 decimals here. I'm going to go ahead and rewrite those right over here, all right, with the same amount of decimal points. So I have 3.320, 3.33, oops, sorry, should be 300 there. So let me go ahead and erase that. And then I have 3.339. All right, so now I can kind of look at these and think, oh, well, this is 3 and 3/100,000ths, and then 320, and then 339. So that makes it really easy to compare these guys. But now I need to look at, okay, these 3 numbers and see how they compare to these. So let's look at 13/4. Once again, I'm just going to look at my holes here, see if that helps. So this is 4 over 4, which is 1. And then this is 8 over 4, which would be 2 holes. And then 12 over 4 would be 3 holes. And then 16 over 4 would be 4 holes. So 13/4 has to be between here and here. Now, to help with this, sometimes we have to be a little bit more specific. Now, so if I take 12 out of 4 from that, I get 3 holes based on what we have. But then I have 1 more fourth left over. Now, you may recognize that 3 1/4 is really like 3.25. And what I can see right away is 3.25 is automatically less than everything else I have here because these are 3.3s. All right, so now I can say, okay, well, that's 3.25. Now I've got to look at these guys. Now, once again, let's look at holes here. So 5 over 5 is 1 hole. 10 over 5 would be 2 holes. 15 over 5 is 3 holes. 20 over 5 is 4 holes, and then 25 over 5 is 5 holes. Now, some of you may be able to do this in your head and get an approximation, that's fine, but I want to write it down just so you guys can see exactly where I'm coming from. Now, what I can see is 21 over 5 is between these 2 guys, so it's 4 point something. All right, so right now we know it's already bigger than everything we have because everything else was 3 point something. So I'm just going to put 4 point something right here. All right, if we need to come back and be more specific, we'll see based on this number because right now this is our biggest number. Now, once again, we can look at the square root of 28, and I'm going to jump. All right, since we've done a few of these already. And so we have the square root of 25, which is 5, and the square root of 36, which is 6. Now the square root of 28 is between these 2 guys. All right, which means the result is going to be between these two guys. So the square root of 28 is going to be 5 point something. Now what I see right away is that's going to be my largest number. So it's going to be the farthest to the right. So square root of 28 is right here. This is 4 point something. This is my next largest number, so it's going to go right here. Now everything else is 3 point something. Now I'm going to take my 3.25, all right? It's my least number, so I'm going to put that right here. Now I can go over here and compare. Okay, which of these is the least? It would be the 3.3. And I can take that guy, and then the 3.320, and then the 3.339. And so that's how everything is nice and ordered. All right, so that's the second piece. Now the last piece is when we're going to give you two numbers and we want to compare them, all right, with less than, greater than, or equal to. All right, so let me go through our symbols real quick, and let me just pull up a clean page here, and you may want to write this down. So when we have something that looks like this, oops, that's not a very good sign there. So this is, all right, A is less than B. A is less than B. So what this is telling us is that A is the smaller number, B is the larger number. And then we could have it this way. This is A is greater than B. So this is telling us that A is the bigger number, B is the smaller number. Okay, if I read it the other way, I could read from B. Notice this is open to B, right? So this also tells us that B is greater than A. All right, and if I read it this way, if I read from B this time, now notice it's pointing at B in the same way it's pointing at A here. This could say B is less than A. All right, so typically we read from right to left, or left to right like normal, but if you read it from right to left, just know it's going to change the relationship, all right, in the opposite way. So I can read this as A is less than B, or B is greater than A. They mean the same thing, but how you would say them is a little bit different. Then obviously if we do this, okay, this is saying A is equal to B. All right, that means they're exactly the same value. Now they may look different, and we'll talk about that as we go through some examples, all right, but we'll get to that in just a moment. Okay, so what we want to do then is put in the appropriate symbol. All right, we either A is less than B, A is greater than B, or A is equal to B as we look at our numbers here. All right, so let's pull this back up. All right, so now when we look at this, we're going to have some fractions here. All right, now when we look at fractions, the denominators are telling us what type of pieces we have. So these are 13ths. Now this is 11 13ths and this is 4 13ths. So if we cut a pizza into 13 pieces and I ate 11 out of the 13, all right, and somebody else, all right, did the same thing to their pizza, but they only ate 4 out of 13 pieces, who ate more pieces? Right? It's definitely this person ate more of the pizza, right? 11 13ths. So we would say 11 13ths is greater than 4 13ths. Okay? Now, when we look at fractions that have different denominators, so notice this has an eighths and this has tenths. You can use a little bit of estimation, or we can get common denominators, and we'll talk about that in just a second. But if we're going to estimate, when I look at 5 over 8, what I can see here is that if 4 out of 8 would be half. So 5 over 8 is greater than half of what we have. If I look over at 10, what I should realize is that 5 out of 10 is half. Well, 4 out of 10 is less than that. So then what I can do is, using estimation, this is more than half, this is less than half, so this would be greater than. Now, if you wanted to compare these so that they had the same denominators, so we'd be in this same situation right here. All right? So we have to find the first number that 8 and 10 both go into. All right, so if I start writing my numbers in eighths, and I count by eighths, 8, 16, 24, 32, 40, 48. Okay, these are the multiples of 8. Now, if I do the same thing for 10, I would go 10, 20, 30, 40. So then I stop here because I want the first number that's on both lists. And this would be the least common denominator for both of these. So what this is telling us is that I can convert these to 40ths in order to compare them. Now, what do I multiply 8 by to get to 40? Well, if I go back up and list, this is 8 times 1 times 2 times 3 times 4 times 5. So 8 times 5 is 40. So then I have to multiply the numerator by that same number to get the equivalent numerator. So 5 times 5 is 25. So 10 times what is 40? 10 times 1, 2, 3 times 4. So I had to multiply the numerator by that same amount. And I get to that. So what I can see right away is 25/40 is definitely much bigger than 16/40, and so that's definitely greater than. So some of these, it's maybe quicker to use estimation. If you don't feel comfortable with that, know that you can always convert these to like denominators to compare. All right. So now if we look at the next two examples here. All right. So I've got -1/6 and -2/9. And so in this case, it may be a little hard to estimate, all right, what numbers is a little bit bigger or smaller. So what we might want to do now is find a common denominator. So once again, what I'm going to do right up here is I'm going to count by sixes. 6, 12, 18, 24. And I usually write the first 5 or 6 out, or the first number. Now what I want to do is count by nines. And I want to stop when I get to a number on this list. So I'm going to go 9, 18, and I don't have to go any farther. So 18 would be our least common denominator. So I can make this something over 18 and this something over 18. Now once again, I have changed the denominator. So I have to change the numerator in the same way. So 6 times 3 is 18. So I need to multiply the numerator by 3. So this gives me -3/18. Now I've changed the denominator from 9 to 18. I multiplied by 2 to do this. So then I got to multiply, all right, my numerator by 2. So this gives me -4/18. Okay, now here's the key. The bigger the negative number, the smaller it is. All right, so it's actually going to be less than. So -4/18 is the bigger number, so it's going to be less than -3/18. All right, now so when we look at this, all right, once again, this may be kind of hard, so I'm going to get a common denominator here. So I'm going to count by 5s. So 5, 10, 15. And look, I've already got a 10 here, so this says, hey, 10 is the common, so I don't have to do anything to this side. I can leave it like this, and I can change this to 10s. Now notice, 5 times 2 is 10, so I've got to multiply this by 2 as well. So 3 times 2 is 6. And what happens? We see that these are, in fact, equal fractions, so those would be equal. All right, let's run through a few more here. All right, and these involve radicals, all right, and decimals, and so let's talk about how to compare these. All right, so once again, when we look at these, we want to find our perfect squares. All right, so if I go through what we've been kind of talking about, the square root of 25 is 5. The square root of 36 is 6. So what I know right away is that the square root of 37 is bigger than this number. So if the square root of 36 is 6, the square root of 37 has to be 6 point something. And that's really all I need to know in this situation, because this is 5 point something, so it tells me this is greater than 5.87. All right. Now, when we move over here, all right, so we can look at this guy. All right, so, and once again, we can think about wholes here. So, -8/8 would be -1 whole. All right, -16/8 would be -2 wholes. And so what I can see is that this is 17/8. So that's a little bit bigger than this. So it's going to be a little bit more than that. So it's going to be -2 point something. And we'll leave that here. All right, so now what we have to figure out is, all right, what is this? And now remember, this is a cube root. So I've got to think of some numbers that I multiply 3 times to get to this number. So I'm going to go through my numbers. So 1 times 1 times 1 would be 1. All right. And I should put a negative here since we're dealing with that. So that's -1. And then if I did -2 times -2 times -2, that would be, so that's just +4 times -2, that's -8. And if I did -3 times -3 times -3, -3 times -3 is 9. 9 times 3 is -27. So what I can see is that this is just barely past -2. Well, -3 times -3 times -3 is -27. So this has to be really, really, really close to -3. So this is just a little bit less than that. So this is going to be our bigger negative number, which means it's actually the lesser number. All right, so this number is bigger. It's going to be closer to 0 than this number would be. All right, so now let's come down to here. Now, the absolute value of negative 3 is asking us how far is negative 3 from 0? Well, it is 3 units. Now remember, in this context, we're saying that we're going to accept this as the positive root, so the square root of 9 would be 3, so those two guys would in fact be equal to each other. Alright, now, this we did the work up here, so this kind of helps us out. So negative 2 times negative 2 times negative 2 is negative 8, so the cube root of negative 2 is negative 2. Now notice this stays outside, and then I have a negative times negative, which means this is positive 2. Now, negative 2 squared is negative 2 times negative 2, and that's positive 4. And I can see right away that 2 is less than 4. All right, so now, all right, 4 examples for you to do. All right, so once again, go ahead and pause this video, all right, and let's see how you do. All right, so let's take a look at these. All right, so when we go through this, all right, negative 2 times negative 2, this is a positive 4. Now, hopefully what you figured out is that this is a little bit, so 16 over 4 would be 4 wholes. So this has to be a little bit less than 4. So this is 3 point something. So what that tells us is that 4 is going to be greater than that number. All right. Now, when I look over here, all right, this is a little bit more challenge, all right, but I think you can probably figure it out, that when I have this, okay, 15 over 15 would be 1 whole. So what I'm left with is 1 whole, and then I still have another 15th left over, so that would be 16/15. So when I look at this, 16 over 16 would be 1 whole, but I'm going to be left with 3/16. All right, so now if I think about it, this is 1 whole, and this is 1 whole. So really it's going to come down to which one is bigger, 1/15 or 3/16. And so I can kind of estimate this, that 1/16 would be slightly smaller than 1/15, but 3 of those is probably going to be bigger than this. So we're going to go with that guy. So 16 over 15 is less than 19 over 16. All right. So when we look at this guy, all right, once again, we're looking at our radical. I'm going to just write this down here. Let me scroll just a little bit here. All right. If I do the square root of 9, that is 3. So the square root of 10 is going to be just past 3. I don't think it's going to be to 3.5. So this is really going to be like negative 3 point, maybe like 1, or maybe 3.2. But that's enough to let me know that this number is a smaller negative number, which means it's actually the greater number. Because remember, the more size the negative number has, the larger the negative number is, the smaller it is. All right, now, so when we look at this guy, all right, so the absolute value of 3.26 would just be 3.26. It's 3.26 units away. So now we got to compare this. So if I come over here once again, 5 over 5 would be 1 whole. 10 over 5 would be 2 wholes. Okay, so 15 over 5 would be 3 wholes. Now, that leaves me, since this is 18 over 5, that leaves me another 3/5. Now what I can see here is that 3 over 5 is a little bit more than half. So this is going to be a little bit more than 3.5 something something. And that's just enough information to let me know that this number is in fact bigger than that number. All right, so that wraps up this lesson. I know it's a little bit longer than normal, all right, but there are a lot of information in here, a lot of estimating. So go ahead and give worksheet Unit 05 a shot. Let me know if you have questions.